what is the radio astronomy and what is radio telescope, and the difference between radio astronomy and usual optical astronomy, or uh, we may say optical telescope and a radio telescope. So I will not spend time on this. So I hope he has explained you in well manner. So uh, before going ahead, once again I would like to explain you about the radio window. This information also you might have uh, received from Parth, that if you see this slide carefully and see my cursor rotation, so this is the radio window which is available for humankind to observe outer celestial objects which radiate radio energy, and which receives up to the earth's surface. And compared to this radio window, you can see this optical window which is much more smaller, and this is because of wavelength, because whatever we see through optical waves or optical rays, those are having wavelength between 400 nanometer to 800 nanometer. And in radio we can see radio waves almost from 100 of meters to 1 millimeter wavelength, or in frequency unit, we can see, we can say that we can receive radio frequencies from outer sky from almost from 10 megahertz to 100 gigahertz. So because of this, this large window is available, a radio window is available to make observations of outer sky. So you people all you are aware with ionospheric layers, and ionosphere reflects radio waves beyond 20 megahertz, and on around 50 megahertz radio waves uh, can pass ionosphere. So this is the graph of that. So this is why we can see uh, outer sky uh, in the radio waves form, out celestial objects. Here actually I just wanted to give for explain for ionospheric height. See this ionosphere is from around 85 to 600 kilometer, and beyond that whatever atmospheric layer is, which is called exosphere. So actually this slide is also, I feel, not much more required, but to for introduction I think this is useful. So this is the solar system, you know, all planets. Actually this is not in scale, of course. Making this diagram in scale is not possible due to space limit in the screen. So I'm going to explain you about meteors. So what is meteor? Before that we should know about asteroids in the solar system. So asteroids, um, asteroids are in diameter from 1 meter to 1 lakh kilometer, and as per study of astronomers, they say that asteroids in the solar system uh, beyond 1 kilometer are around 20 lakhs, and less than 1 kilometer, those are more than 20 lakhs. So this is their prediction, and so this huge uh, quantity of asteroids are in our solar system, and particularly between two planets, and that also we'll see. You can see this uh, another picture here. You will see that uh, around around Earth there is very small quantity of asteroids near Earth, asteroids, and uh, between Mars and Jupiter, there are asteroids belts, and those belts are also those asteroids also classified by astronomers. So you will get the idea of these asteroids, and this is the some conceptual film of how asteroids are rotating in the solar system, and one of them or few of them, uh, they enter in the earth orbit, or due to earth gravitation, then they try to come in the earth atmosphere, and at some certain occasion or certain incident, they try to reach on earth surface. And then actually there are three types that we'll see in the next slide. So meteorite is that what is rotating in the earth atmosphere, or beyond earth atmosphere. In Marathi it is called ulkav, and it is meteorite. uh, Sometimes we see the meteorite in bright form also, and sometime may not. But whenever that meteorite enter in atmosphere, and it brights, which is called in Marathi ulka, and whatever we see, that is meteor. It is called meteor. And whenever it gets reached up to earth's surface, then it becomes solid, I mean remnant, its remnant uh, reaches to earth, and it remains there in a solid in solid condition, and which is called meteorite. That is ulkashma, means ashma means stone, dagad. This is the ashma created by, or uh, generated by ulka, means remnant part of ulka. So sometimes uh, some pieces of comets also are there. If some small part enters in the same way, that also became a meteor, and then meteorite. So in English it is very easy: meteorite, meteor, and meteorite. So sometimes that meteorite enters, or it stucks in it gets what we can say in the land also. So some, we don't know, it hits in very strong velocity, and may try to reach under the earth also sometimes. So here one website link is there. You can, I'll take, or you can also find out using Google search. It is a Wikipedia web link. They searching meteorite here. There is a animation of meteorite, how it turns into meteor and meteorite. So this is very good uh, animation. So whenever meteorite enters in the atmosphere, and after passing in the atmosphere, finally, as a tail, it travels, creating ionized electron, and due to this, ions gets created, and those ions actually, uh, they radiate some particular wavelength. Whenever, in this situation, suppose some lower frequency radios are in the ionosphere, uh, those gates, re- the reflection happens in those radio waves. And if we note that the reflection of those radio waves, so after uh, observation or recording of radio waves, we can get the information of meteors or meteorites or meteorite also. In this picture, it has shown very much clearly. See, the meteorite is entering in the Earth atmosphere, and there is one transmitter which transmits some lower, transmit in lower frequency band, and some around some few hundred kilometer distance is between the receiving antenna. And if that meteorite is entering in the atmosphere, it that those radio waves gets reflected, and in the receiver, that reflection gets recorded. So this is the technique, and it is very modern technique, which is developed. Actually, this was developed in 1940 50, but actually that time radio waves were uh, much more. That time radio astronomy was developed, and all people in the world, they were much more interested to observe radio objects of faraway distances. And maybe because of that, this topic, or this observation, or this, or monitoring and recording of meteor was not got much more preferences, I feel that. But now, and also, only few European countries were ahead regarding this science and technology. But now they have made very nice progress, and now we are also following them, or we are also using same technique, and we are trying to create some setup also. So per day, more than 2 crore small or big or medium asteroids enters in the Earth atmosphere. Uh, Astronomers say that their weight is around 15,000 ton, and out of few crore meteorites, 90 to 95% those gets burned completely, and reaching meteorites up to the Earth's surface. And those are their quantities only few hundred, and we don't know where those are getting called. Maybe our land surface ratio on the Earth is much more less than sea, or so that is why we don't know where those gets fall. And here they have shown, as per the study, uh, when what time are those asteroids gets fall, enters in the atmosphere during or after sunrise, that ratio is quite high. So uh, these are the few pictures of meteorite. See the small pieces which are so tiny we can take in our palm also, and such a big uh, we can which we are this has fallen from sky also, and because of meteorite, there are craters are also formed on the earth surface. So this is the very large crater in South Africa. The diameter of this crater is around 160 kilometer, and this is the very famous crater of Lunar, which in diameter is around 1.8 kilometer, and a few meter uh, diameter craters are also on the earth's surface. I have not actually, I couldn't find. I mean, I couldn't prepare those pictures, but you can find on Google, searching the Google. So this is the very simple setup is used to observe meteor or meteorite. So we require some transmitter, which is called prakshapak, and this is the transmitting antenna is the essential part of this transmitter. Of course, another side, another antenna is also required for particular transmitting frequencies, and this is the receiver part. Now this receiver is available in dongle itself, and some computer or some or you can say nowadays this technology has become very easy. You can receive those reflections uh, through this receiver part or dongle, and in your PC you can record that data in various forms, waveforms, using various softwares. Uh, and then another work remains, that you have to plot this data from the images, or you can you can analyze this data in different ways also. So this is the very simple technique which is getting used in mainly in European countries for meteor monitoring recording, and general term is used for this technology is just radio meteor. So you can find out, and this is the more this picture little bit uh, explains little bit more information. uh, this is the transmitter and dipole type antenna. You can see the dipole, and in the receiver they actually here initially people used to use normal receivers, means particularly uh, designed for this particular frequencies, and then for sampling old technique was there, and software is there, and you can see the reflection or in this another image, and by analyzing those images in different ways, you can find out the direction, and then sometime height of the meteor route or distances, etc. This now very popular method for this is using dongle. Here I am showing the picture of RTL SDR dongle, and this is the uh, flow chart. This is the monitoring diagram, monitoring image, monitoring
Waterfall.
process of that flow. This is called a fall
Waterfall. Yeah.
a waterfall chart of the uh, RTL SDR program. So here, suppose if you are recording in particular frequency, so while recording you will get the reflection here. Some small as shown because their antenna was designed particularly for 162.525 megahertz, and they have observed this some reflection, and that is why they have recorded this uh, phenomenon here. So one more, this is the nowadays theoretical study has also came out, and relative scattering, scattered signal in frequency domain they have shown. Then scattering duration also they have shown. So here you can see that uh, less than 50 100, you there's a relative scattering means power will be high. So that is why these people try to use lower frequencies for radio meteor observation, and scattering duration is also high in low frequency, and we can get then better reflection, or we can observe for a long time duration. So that is why this preference has given. And here, of course, power and those units have given at their patterns they have given how due to reflection how there will be some sort of oscillations, some sort of damping type oscillations in the recording. So what is the difference uh, between observation of meteorite in optical and radio? So compared to, I mean, radio is also easy, but for radio also, optical is also easy. And nowadays for optical also 360-degree cameras are there, and people use those cameras for continuous observation of meteors. And here we can get little bit simplicity for recording, and for this uh, there is not need of sky should be clear. Even in cloudy sky also we can observe meteors in radio form. And because of this then we can record meteors which is not possible in optical uh, optical spectrum. And sometimes even in the daytime also we can make observations and try to record meteors if possible. And far away meteors also, recording of meteor is possible in radio form. And nowadays this technology is getting developed that we can get the information of height of meteor and mass of that meteor. Actually, I'm also trying to uh, collect this knowledge, and as a part of this, I have started working on this. And as a part of this, actually in India, people used to observe and record meteors in radio form in using FM bands. But I have studied little bit more, and I find that in lower frequency, it is we can get more informations. But our problem was to find out transmitter, because in India high power transmitters are very less. And then I came to know about ISRO's uh, radar transmitters. Those works at 53 megahertz. And now I have developed one antenna, a dipole antenna for 53 megahertz. And now dongles are with me. Special dedicated laptop is also there. And maybe probably next month I'm trying to uh, build a setup for a radio meteor, and now I am finding suitable location for radio meteor. And before that, I have not only designed only antenna, I have designed proper balance for that, proper band pass filter for that low frequency, and I have collected. I means I brought proper LNAs also, low frequencies. So I'm also now searching interested manpower working for to work with me, because I inquired all over in India. I have not found anybody is working on this technology. So I have started, actually this I have started uh, more than 5 years, and initially I kept collecting the information and trying to understand this science and technology. In India, there are many organizations, many people. They work on Meteor, but their studies mainly in optical and theoretical, and on means their studies on uh, received meteorites from sky. So in the radio meteor, very few people are there. I mean, I don't know how now this work will go ahead, but we are trying to make this setup. So this was my uh, my presentation. So I give preference uh, for discussion. So here actually I have completed my presentation. So I think we'll go now. We'll turn to discussion, or if anybody is having any doubt, they can ask me.
Can I ask the question?
Yes, yes,
The meteor is hardly for few seconds, milliseconds, something like that.
yes,
So catching it in radio form, and then somebody waiting for the that radio signal to come exactly, reflecting the transmitter, and then catching by the receiver and all that, looks to
yes,
be very matter of chance.
yeah,
It cannot. It is not a sustained activity.
yes, yes, yes. This is a little bit complex task, we can say. But here actually, development of setup is also more important than sustainability of this, as you said, that is also important. So let us see now how this works, or how this
Because I will
goes
tell
ahead.
you, the other celestial objects, even in daytime or in night time,
Ah,
even the solar system like Jupiter, the Parth was explaining about the Io Parth, Io and Jupiter, na.
yes,
So he was explaining that. So those things can be monitored very peacefully and leisurely. I mean to
yeah,
say, for the duration. But the meteor is looks to be like a chance.
yeah,
It's a chance. It's not
yes,
a.
yes, yes,
Hmm.
yes,
Even if you know that there is a meteor shower or something like that, still
ah,
there is a chance, because
It
you
is, yes, yeah.
how to transmit, and then how to reflect, and then how to catch those reflections.
yeah, yeah, yeah,
It is almost like a accidental thing.
yes, yes, yes. This is of course like other astronomical observations. We have to keep searching, and then we'll get. Yeah,
And that is also for milliseconds.
yeah. Only few seconds. That is why, means in my PPT you can see that uh, so this is the theoretical observation information is available. S-
Hmm.
yeah, so if you see this they have shown scattering duration from 60 second, means less than 60 second, but it suddenly gets reduced uh,
Hmm.
around 100 megahertz. That is almost very few seconds.
Hmm.
Yeah.
So actually, what are the records of radio receptions, radio evidences of meteors? How many are the records? Records also must be very few.
Yeah, yeah, yeah. Actually, now in Europe, there is a separate organization, International Meteor uh, Organization, and actually, I have not joined them because to join them, nothing is in my hand. So, actually, this took 5 years to come at this stage, and also much more work is required as a part of this. Shall share my antenna photo with
No
you?
problem.
Yeah,
Go ahead.
Yeah,
I will just share.
Meanwhile, Parth, why I was asking this question is that meteor is not a radio object. Okay, it is only thing that you are transmitting some radio waves. Okay, and they are going to get reflected like a mirror from a falling object. Okay, and then you are means trying to catch them in the receiver, right, Parth?
yeah.
So it is not a
Also,
radio object. I mean to say, it is not a
it
radio object.
yeah, it is not a radio source.
Yeah, yeah, yeah. It is not a radio
It
source.
is
Mhm.
it's a reflection.
It's a reflection. It's like a mirror.
Hmm.
Mhm. Okay. So I talked because to get the clarity. Actually,
Can you see this photograph?
no.
No,
We are seeing only the
Explorer.
folder. Folder.
Hmm. I
Uh,
have uh, I have sent the image in chat
Wait,
It's
wait.
okay, but why he is not able to?
No.
because of you'll
What?
have to stop the sharing and you'll have to select share my entire screen.
Share my entire thing. Means I have done that, na? No screen.
It's it's not up to you. It's up to
It's
Mr.
him.
Phakatkar.
Phakatkar, right?
No, no. You are
No,
screen
no,
sharing.
no, you are the Zoom.
Wait, wait, wait.
Yeah, yeah.
I think. Now can you see?
No. Now.
Yes.
Yeah, yeah.
So this is the particular 53 megas antenna. It is the return loss performance of that antenna using two different types of balloons, and I will share photograph of also same antenna. Then you will get the idea of. Please wait me. Let me 1 second. This takes little bit small time. So actually, for referring, nothing is available. In
Hmm.
That is the one point, and almost I have sent emails to many people, more than 20 people, to give me this information, but nobody, means academic people, but I have not received because any reply from them, explanation of them. The reason behind this is many people are not aware with this. That is also the reason actually,
Hmm.
because nobody has work on this. So that is why I have started working. I'll show you the actual picture of this antenna. Then you will get and what is happening if we want to do something right from scratch, or right from I mean from zero, just searching guidance, so it becomes very easy. It becomes very difficult to come to this level. So, uh,
I have put one question actually,
huh,
in which in the chat box. It is
I will see.
yeah.
Let me show you the actual picture of this.
Your screen is stuck up now.
Huh. Now I will show you the picture of this antenna.
Hmm.
Can you see the picture?
No.
No.
Wait. What is happening? Can you see now?
Yeah.
So this is the dipole is around 3 meter. Reflector is little bit more than that, and see, this is the 5 element antenna, which we have this SWR measured at GMRT. This is the handheld network analyzer. This is my colleagues. So now I have achieved something up to this stage. Now let us see uh, how to go ahead. And now actually one more thing is there, that Parth was with us, but now he is also, I think, living.
No, we are he is there only.
I mean, he is very much expert in software, these Tungal techniques. So anyway, he will be in our contact, but let us see now how things go ahead.
Yeah. You said something about NARL Tirupati using their radars
Yeah,
for
I have
meteor
visited.
tracking.
Yeah, I have visited. They are having radar facility. Eh, uh, they use 53 megahertz, and we got information that at least 800 kilometer, your receiver should be a maximum 800 to 1000 kilometer. That also knowledge we have to get from experts from abroad or anywhere. And if we get, now we'll start, means this is on pure amateur level. So after testing of this whole setup, means antenna, dongle, laptop, now we'll try to find out suitable locations to observe this 53 megahertz radar frequency traveling towards southwest, southeast from our location.
I asked about that question was about that ionosphere. You have
Ah,
shown that 100 megahertz line was showing bent and going to the space, into the space, not reflecting back. So what was that bent actually? Bend.
uh, 1 second.
It was the third slide
Uh,
in which you have shown that the ionosphere is reflecting the radio waves back to the
uh,
earth. Okay, like ham. But these radio astronomers, काय Parth? What do you feel about it?
So in
Huh?
this case, the meteor is reflecting the radio waves, and if they don't
Hmm.
reflect, the waves will go in the sky. But if they are reflected, the meteor is detected, and
Oh, I
there
see.
is a
Okay, thank you.
See, the military having this use during the war, the
Uh-huh.
enemy should not receive the signals. So they what they do, they know meteor shower where happening, so
Uh,
they send the messages in the sky and reflected messages received by their ground station. This is how
uh-huh.
there is a link right now operating from Hyderabad to Dehradun, and their
Uh-huh.
routine is to solely depend on the meteor.
Oh, I see.
So the meteor shower has a very good importance in military,
Ah,
and
this
it is
one, this
being
one. So this ionosphere, you have shown that 100 megahertz line is going in the space and not reflected back. Because of ionosphere, there is no meteor, sir. Rabde sir, there is no meteor shown in this picture. This picture is showing the property of an ionosphere of reflecting the waves.
See, Makaran, the
Huh.
atmosphere it reflects the radio waves, but
Right.
sometimes our focus is on meteor. So radio
Yeah.
waves are sent to the meteor, and the
Uh-huh.
reflected waves are received. If there is
Yeah.
no meteor, you will not receive any signals. But
Okay.
this meteor shower is a very common phenomena, and they
Uh-huh.
know which area this going to
Yeah,
have
yeah.
the meteor shower.
Yeah.
So
Sir, that means whatever we were doing optically, meteor shower observations and those star parties and all that. So same way, radio also can be we can do.
yeah. See,
Means
this
means
particular project, what Sudhir has taken up,
yeah,
is
yeah,
to track certain meteors which
yeah.
may stuck with the Earth. So you have to monitor them, their path, and which direction they are moving. If they are
Mm-hmm.
not coming on the Earth, then nobody bothers. But if they are coming on the Earth, they need to be monitored and destroyed on time. If I
Yeah,
mistake not, please correct Sudhir what I have said.
Yes, actually, the that sending radio waves to asteroids, that is different, and just observation of reflected radio waves due to meteorite, that is different,
yeah.
because yeah.
Yeah. And then concurrently, what I mean to say is that just now the amateurs and the common citizens, they go for the meteor shower observations during night time and all that, because all the meteors all around the year other than monsoon period are now well known to everybody, and they do go for observations the whole night and all that. So during that time, Sudhir sir, during those occasions, as Rabdeji was telling, we can have such setup of transmitter and receiver, and to demonstrate the meteor shower and the reception of those waves,
I
bounce
think
waves.
I think let student ask question
Yeah,
so that
I'm actually was about to ask them to, but we are started talking because of to them, for them only.
yeah. So Karthik and others, please start. Harsh Jagtap, Karthik.
Yeah.
Okay, Pooja, please ask questions. Don't be shy. Please ask.
हा, विचारा, अगदी काही प्रश्न असतील तर विचारा.
There's the problem.
Language is no barrier. You can ask in
हा
Marathi
हा
also, or English
हा,
also.
तुम्ही मराठीत विचारा, काहीच
No, they
प्रश्न
are
नाही.
not conversant in Marathi. They will ask in English only, but still they are not. They should actually.
मला एक प्रश्न आहे.
हाँ बोल.
हा, बोला बोला.
Like what software do you use for processing the data?
Actually, what software name? Actually,
SDR
there
sir.
are various. मला वाटतं पार may also
Huh?
tell. I'm not remembering words of names of the.
SDR sharp वापरला होता आपण, SDR प्लस प्लस,
Yes.
SDR console.
That is used for receiving the data, na?
हाँ,
So like
so after
after
that
receiving the
processing
data,
के
you
लिए,
process the data, right?
so I
And
think
processing
waterfall
what?
gives you an idea if there's a meteor happened or not. बाद में you'll have to shift to your system to something called as a passive radar.
Okay, so you record the data, right?
Yeah.
हाँ, IQ samples record करते हैं using GNU radio. You correlate them, and using GNU radio you can do this, or you can use MATLAB or something. You output the data from GNU radio into some file or something, or into ZMQ, and then process it using MATLAB.
Actually, I remember now. One program was written by my colleague that was in MATLAB only. So he said, but actually there are few difficulties also, because the data size is quite big, and that program, whatever he,
Yes, you will have to
yeah,
incorporate something like an AI model or something
yeah,
to take out transient analysis, like we do with FRBs.
yes,
Something like it should record a data for 2 minutes. It should look if there's a meteor there or not. If there is, it will save it. If there is nothing in the data, it will trash it in.
Okay. So one more question, since it is not a radio source object, radio object, what we are sending is the what form of waves, radio waves? 100
You can
megahertz.
use any.
100 megahertz.
No, I
No,
think
no, no.
Sudhir ji made the Yagi for 53 megahertz
53.
at
Actually, this is known transmitter,
Uh-huh.
known transmitting frequency.
Uh-huh.
So actually, I have explained that to observe radio meteors in radio waves, low frequency is required of
Mm-hmm.
any transmitter. So
Mm-hmm.
in European countries, they develop their own transmitters for radio meteor science and technology. Mainly those are in 30 megahertz, 32 megahertz, because their system is totally dedicated for this purpose only. And
Mm-hmm.
in India, uh, such type of dedicated technology is not available. So we are now trying to develop or create this facility in this manner,
Okay.
because low frequency transmitters are very less, and their power also should be sufficiently high, which is not available. So that is why we are struggling to develop this and this setup, and the what the area of our country is also quite large. Variations are geographical variations are also there. So many challenges are there to develop this setup.
If there are no questions, we can close the sessions today.
Okay.
Any questions? Any more? Sir, Parth, can you make the concluding remarks?
Yeah, I think we all learned a lot about radio meteors. You got more idea than probably what my introduction was. So I thank you all, and I thanks Mr. Phakatkar for joining us today.
In spite of his busy schedule, he is in GMRT right now.
Yeah, he's in GMRT right now. That's his GMRT office.
Yeah, I need to be here today because of my colleague. Actually, my plan was to come there and
Yeah.
have lecture offline, but
Today morning he messaged
yeah.
me saying that he cannot be
Actually, it
here.
was decided yesterday late night, and then that is why I asked Parth, "Are we meeting offline or online?" And he said, "Yes, offline only." And
It's
then
offline.
and then offline turned into online. So sorry for that. Means at the last minute, I need to change my
No,
the
no, no
decision.
problem.
Yeah.
We have
No,
no
no, it's
problem.
okay, sir. Sir,
But
see you.
yeah,
Sir, see you at
certainly.
GMRT.
Yeah, certainly. When you, I don't know when you people are planning to come here. And one more thing, whatever students are now participated in this school, I will, of course, I will ask their contacts to Parth, and if
Yeah,
they are
please.
interested, yeah, if they are interested, they can join me.
Harsh or Karthik, Pooja,
Yeah.
you guys, please if you want to do a project in how to handle the radio meteors, it's a very ambitious project.
Unique
It's
opportunity. Unique
yeah,
opportunity.
it's unique because
Sir, can you
it has. I'm saying it's a unique opportunity. You should join this project because this is a once in a.
Yeah.
This was never been done before.
Okay. Whom should we contact for this?
Sudhir Phakatkar, sir. I'll
Okay.
give you his number.
Okay.
So we will be working under him, right?
Yeah. When
Yeah.
we will visit the GMRT, we will see his efforts, his development equipment and all that. We'll see that.
Yeah,
Okay.
sure.
So visit is
Sure.
scheduled now.
Yeah, before coming, we'll discuss.
Yeah.
We'll finalize your visiting
Yeah.
date. And
Yes. Yes. Definitely.
Okay.
Kaushal will also help us.
Now I request Makaran to propose vote of thanks.
Yeah. On behalf of our group Tech Forum also, because we have taken the assistance of Tech Forum, that's why I'm thanking them also to conduct such kind of meeting. Okay, our usual plan was different, but still we did this, and Phakatkar sir also helped us in this endeavor. So I thank all the participants as well as Mr. Phakatkar for the presentation. Thank you. I will stop
Okay.
recording now.
Okay.
Yeah. So meeting is over. Thank you, Sudhir, for joining.